Cool. We're good to go.
Thank you, Nathan. Let me share a portion of my screen. Let's see. Okay, so can you see the screen? Tunes from the AI Frontiers, and hopefully the slides change. Okay, yeah. And feel free during my lecture to, what's going on? To have questions posted in the chat. And I have the chat on the side here so I can see them and answer questions as they come. So thank you for that introduction. My domain is in music informatics, more generally digital signal processing. And I joined KTH in 2018 in the summer. And some of the courses I teach are music informatics at the master's level, as well as machine learning at the master's level, and then machine learning for media technology. And I have fun applying machine learning to all kinds of music data. So this goes without saying, machine learning is a set of methods for making machines learn from data. It's obviously one of the hottest areas of research in AI today, and hugely successful now due to a confluence of data, computational resources, advancements in efficient and effective algorithms, and massive amounts of capital being thrown at the use of machine learning for any number of applications. Folk music, on the other hand, very different. A historically motivated categorization of musical practice among common people sharing a regional identity. So here's a small snippet of a accordion player in Ireland named Johnny O'Leary playing a tune.
Now I need to play something there for the young guys. It's a young girl going to
dance. So that's him there. And he would typically play for dancers. And he was known in his area for playing sets for dancers. And this kind of music accompanies practices like dancing or storytelling. Obviously with songs, you have lyrics and these tell a story. And folk music is passed orally with provenance. So I learned this tune from so-and-so who learned it from this tune, which comes from this area. So that's machine learning. That's folk music. And what about applying machine learning to folk music? Do we create AI folk or faux folk or traditional music? And by the way, I have a tendency to have a capital A and a lowercase I because there's no question that AI is artificial, but there is a question as to what kind of intelligence it shows. So how might we take the music played by Johnny O'Leary, encode it somehow in a computer to generate more of the same, and then have it interpreted by somebody like me on my accordion with my little dog on top. In 2015, or actually this is from 2017, we were exploring this topic in a article in The Conversation, which is more geared towards academics. And the editor called this machine folk and said that this kind of music shows technology's creative side with AI. So you can read that article, but the name machine folk stuck, and that's what I'm a practitioner of today. So let's have an example of machine folk. Here is The Boys of Ballinabura. That is a title that was generated by a machine learning system that had learned, we'll talk about the system soon, but it had learned to title and generate this kind of sequence of tokens. And this sequence of tokens is decoded from, the one-hot encoded outputs of a neural network, and you have such things as meter and key and measure designations that say begin repeat, and then you have notes, etc., and durations, and then an end token. More common to have this printed in music notation, staff notation. It looks like this. So I'm going to play The Boys of Ballinabura on my accordion. Now, what's actually written there would sound, if I were to play that, would sound like. And played like that, it's boring. It's far from how this kind of music is interpreted with dancers. And a lot of this kind of music, folk music, traditional music in Ireland, comes from the use of ornamentation, triplets, cuts, and rolls. And so to take this from the generated output of the system into a convincing piece of Irish traditional dance music, it takes a lot more to bring that into reality. So the musician contributes a lot to these transcriptions. It's not just the computer generating tunes. By the way, there were no changes other than those ornaments and various variations, no changes made to this tune. It's basically these are the bones of the tune, and one plays around and varies these bones when executing the tune. So that's the Boys of Berlin-Borough, composed by a machine called the FolkRNN system, which I will talk about. So first of all, some background. How did I get here where I'm at KTH? And a large part of my free time is spent looking over music that's been generated by my machine learning system on the accordion. In 2015, there was this great blog post by Andrej Karpathy. You'll probably know him from the Stanford Computer Science course in machine learning. He's also he was working on robotics at Uber, I believe. He's a superstar in the machine learning world. He wrote this great blog post on the unreasonable effectiveness of recurrent neural networks. A basic recurrent neural network looks like this. You have a memory state inside of the network that keeps track of what it's seen before, and this is a representation of the network that is unfolded over time. So a standard neural network, feed-forward network, would just be one of these columns here. You put some inputs in this case it's one-hot encoded. There's some transformation that happens, a nonlinear affine projection, and then you have some output, and then a decision is made. But a recurrent neural network is one where at least the internal state is maintained between successive inputs. Also, we have the output is connected to the input, and so whatever is sampled from the output becomes the new input. And in this case, this network is coming up with a very probable word that starts with the letter H, and H-E-L-L, and then O would hopefully be the last one if it's, or in token if it's hell. And so in this case, the network has written hello. And you've got these matrices which control the information that flows between time states and between layers, whether it's the hidden state to the output layer or the input state to the hidden layer. And Andrej Karpathy showed with some code in his blog post that you can train this kind of system, in particular a long short-term memory network, to produce text that looks like Shakespeare. And so you have characters in capital letters, you have punctuation, you have words, you have sometimes not real words, but Shakespeare oftentimes created his own words, unique words. So that's not completely out of style of Shakespeare, but it looks like Shakespeare produced by this system. He also trained it on a bunch of Wikipedia articles, and it could create long paragraphs that were nearly coherent. He also trained it on XML and HTML code. And what's interesting is that the system, if it's producing one character at a time, it has this open, this tag that begins. It's got to close the tag as well. So it's like a period, ending a sentence with a period. So it knows that this element in XML requires that close tag. But also, you go all the way down here, several steps later, and it has a concluding token, with the slash. And so it maintains the states, this memory, over a large number of steps, which is amazing. So he called this unreasonably effective. So he had some source code that was linked to this blog post. And one Saturday morning when I read this article, I thought, well, this code's available. Let me go through and install Torch and all the libraries I need to play with this, and let's try applying it to some music data. So I found this data set of tunes, folk tunes that are written in a textual notation. And all we have to do is replace what is ever in the data, the Chinese Shakespeare data set, with this large text file of 1,100 tunes. And this is basically what the architecture looks like. You have 3 hidden layers, each one with 512 units. Each one of these, we'll look at the mathematics of this in a second, but you have an input that's one-hot encoded, 135 dimensional. You have an output that's you sample from based on some softmax output and some multinomial probability distribution. And again, you have a one-hot encoded output, which becomes now the input to that. So that's the FolkRNN version 1 architecture. And the results were not very convincing. It's not really a folk tune. It has some nice musical properties to it. Starts up high, goes down low, all the way back high, and then jumps back down, and it feels like it's resolved. So it's only 1,100 tunes. Let's use more data. There's a great website online called the Sessionorg, and this is where it's a crowdsourced repository of Irish traditional dance music as played around the world, and there's hundreds of, maybe thousands of users that have contributed tens of thousands of transcriptions to this data set. And it's not a hard problem in order to find the archive of this large data set. Here's an example from the database showing a tune called Drowsy Maggie. It's a reel, it's in 4/4, the key is E Dorian, and here's all the notes that come with. So we're just going to model this large text file, which I cleaned up a bit. We're going to treat this like the Shakespeare data and have the LSTM generate 1 character at a time, similar things. And after about 100 epochs of a network trained on this data, it starts to produce what look like separate transcriptions. So here's one called Aori Bowl Down March. It's in 4/4, it's in D major, and here are the notes for that. And then it goes on to the next tune. So here I'm going to play a tune generated by the first version of FolkRNN. Now up here in the large music notation is what I play. This is a result of correcting or adjusting the output of the algorithm, which is down here. So there were some parts of it that I just didn't like. It didn't fit, but I like the main idea of this tune and decided to keep it, keep those parts. So I consider this a collaboration between myself and the algorithm. This is Sore Pike's Cat. So another slight difference, how it's written, if I were to play it as written. Very straight, but this fits more a dance called a hornpipe, which is broken, has a broken rhythm. Dot, 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 dot. So this is another way that if you were to have a computer synthesize this as MIDI, it would come out sounding quite bland and not appropriate to the tradition in which the training data exists. So it helps a lot to have knowledge to bring to the output of these computers, and we'll get to that important lesson later. So we had this system, actually 3 different versions of this system, generate 100,000 tunes in 34 volumes, and you can find all these volumes. Sorpike's Cat is in there, as well as many others. In these at this website, we decided to, as it appears in print, let's have a way to listen to it. So we created a website called the Endless Traditional Music Session, where we synthesized about 36,000 of these transcriptions using a performance model and taking the MIDI and creating MP3s from it. Every 5 minutes, 7 of the 35,000 would be selected for a set, and a person would be able to go to this website and listen to this set of tunes that were randomly selected. It turned out to be a kind of a popular thing. Word got around to a call waiting company in the United States who said, we'd love to feature your algorithm as an artist of the month. And whenever somebody calls into a business that uses us and our music, they will hear, while waiting to speak to a human being, they will hear the music of FolkRNN. So that was done for a month somewhere in the United States, and no ill effects reported of that. We also decided to go back to the session, the people from whom we took this data, and in the discussion section, we decided to ask, listen to these tunes generated by AI and tell us what you think. And here's some of the comments. A computer that noodles, that's all we need. They're terrible. It's crude turntabling without the sense of a musician familiar with the significance of various motifs. You should teach it to dance first. That was an interesting comment. And I think it's reckless to send 3,000 of these tunes into the world. So some people just thought they were terrible. Other people thought they were dangerous. So what we had created, FolkRNN, it's nothing fancy. It's just a vanilla LSTM, and the contribution we made was designing a vocabulary that was very efficient for the kind of music we were modeling. In this case, Irish traditional music, but later on Swedish traditional music. And we described this in a 2016 paper. There's a GitHub that's still there. It uses Theano, but there's been a recent port to PyTorch, which is much easier to use, much more up to date. So I encourage using that if you want to explore this. But essentially, we created this vocabulary with 7 different token types, from transcription, meter mode, measure, pitch, duration, grouping, 85 different pitches in the music, and only 7 meters and 4 modes. We removed all the ornamentations and titles. We transposed all the tunes to the same root. And we did this in order to clean the data and make the machine not have to learn so many different concepts. We wanted to reduce the number of concepts it had to learn so that we can maximize the amount of data that we had. In the end, we used something like 26,000 transcriptions after cleaning and removing all sorts of extraneous information. So having a model with only 5.6 million parameters, and you have only 26,000 sequences to train on, you want to avoid overfitting, and dropout will only get you so far. So designing this vocabulary was an important part to the success of this system. And we also stopped going the route of modeling individual characters and instead used tokens. And so instead of the machine having to learn im:4/4 space, we said, we're just going to break these into tokens. So im:4/4 is going to be 1 token. one of these dimensions in the one hot encoded space, and then the key is another one. And so you have several of these multi-character tokens and many single character tokens as well. B comma, just that comma would be attached to the B, and it refers to a particular octave in the scale. So this helps. So here is the FolkRNN version 2 architecture. It's the same defaults as the first one, except now we have an encoding that's different. We have a 137 dimensional space in which to encode and then sample, and everything else is the same. And the end result is about 5.6 million parameters. So we decided to experiment with this and involve it in music composition. So there's a human in the loop now working together with the trained system. So I provide an idea, the system processes it, suggests what should come next, and together I may adapt that, and together we cycle through to create some tunes. This is as opposed to just having the system run in the dark corner of the building and have it produce millions of tunes. Let's embed it in the creative process. I explored this in a 4-part blog post about how might one feel or experience this assistance of music composition, and I created some compositions in that vein. We created a online system, FolkRNN.org. You can navigate there and click compose, select different models here, select different parameters, different settings. You can even include the start of a tune in ABC notation, and it'll output a transcription that it generates. And you can go back and forth, cycle through like that. So here's an example of this idea. I took the theme from Close Encounters of the Third Kind. So I'll play that. So this is the famous motif from this movie that has numerical, it's like communicating with the aliens of these fundamental quantities. It's got the minor second, it's got the major third, it's got the octave, and then the perfect fourth, and it's sort of the universal theme song of the cosmos. If we don't share any spoken language, hopefully we can communicate with the aliens using this motif. So I gave this as the inputs to FolkRNN, and I asked it to autocomplete this, and after a few trials, I came to a very nice reel. It's one of my favorites. And this is the Close Encounters of the Real Kind. So that's the real Close Encounters of the Real Kind. And hopefully if the aliens coming to us can speak some Irish music, they would understand that. I composed more serious pieces with FolkRNN, such as these. You can hear them on my SoundCloud page. And I explored using FolkRNN to autocomplete Christmas carols for a couple of years, and that was quite a lot of fun. Other than me, other people have explored this. My colleague Oded Bental, who's a professional composer in the UK, composed Bastard Tunes, a 3-movement work using material generated with the FolkRNN system. And you can see these on our YouTube channel, The Bottomless Tunebox. Also, one of the interesting things, being an engineer, we try to avoid failure. We try to engineer out failure. But what we find is that failure can be very interesting for composition. So I wrote a piece called 8 Short Outputs, and this used 8 outputs of the FolkRNN system, which did not quite cut it in terms of Irish traditional music or the data that it was trained on, but nonetheless had some interesting musical ideas. One of the pieces is called The Humors of Time Pigeon. This is a computer-generated title. This piece was generated by the version 1 of the FolkRNN system, and I'll just play this brief composition, The Humors of Time Pigeon. So the system utterly failed to create a plausible tune that would be heard in Ireland or within that tradition, but nonetheless, the title and the musical material excited me as a composer and led me to work with it, this failure of the system. We've worked with a variety of other professional musicians and composers, some Irish, from the Irish tradition, others from many other kinds of traditions, including classical music, to see how they would approach the 100,000 transcriptions generated by a system or using a machine learning system in the process of composition. We've held several concerts and workshops around this, and at one concert in London in a 1,000-year-old church, there was pieces for organ. The melodies were generated by FolkRNN, but they were harmonized in the style of Bach chorales by another system, Deep Bach, and they were played on organ in the church by a human organist. So here's just a brief excerpt of one of those. So all rise, you know, it sounds as if it is a piece of religious music. No surprise there, it's played on an organ in a church. So you can hear much more at the Bottomless Tunebox, a YouTube channel that we've created. But also in this process, we had some interesting interactions with the media. The Daily Mail is a newspaper in the United Kingdom, not really known for its accuracy, more known for its political bent on the right-hand side, conservative side. They got word of our experiments with MUSAiC AI, and they said, can we write a story on this? And can we use an excerpt of AI-generated music on the article? We said, sure. We told them a bit about it, and then they wrote the story and renamed our algorithm Bot Dylan and said it writes folk songs and not tunes. The rest is okay. And then they included, we linked to a video at the Bottomless Tunebox, and they took a 30-second excerpt of that, and this is what readers heard. And the comments were open for a while, and here's some of the comments. It sounds very neat. It's missing the human element. That's it. I'm not impressed. Sounds like a robotic Irish jig. Totally lifeless without warmth. Much human, tuneless junk passes for music today isn't much better. No, no, no. Isn't music robotic enough these days? Have you lost your soul? You're making humans redundant. and this AI is just so non-musically untalented, lazy nerds, that's me, can infiltrate the world of true music. So some people are offended by involving AI in the music practice. But there was a problem. The excerpt taken by the Daily Mail was not of a AI-generated tune, but of a real traditional tune that was played in a set of 3 tunes, only one of which was generated by AI. So these people were very biased in terms of listening to something they believed was generated by a computer but played by humans, and thought it was awful, but it was actually real. We decided to explore this a little further and ask, how difficult will it be for a professional musician to produce an album using this computer-generated material that would be judged successful within the idiom of traditional music? So we hired a professional musician in London who is a practitioner of Irish traditional music. He's won awards in Irish performance on not a typical Irish traditional instrument, a melodica, but Darren Barnarcy. We gave him the 100,000 tunes in 34 volumes, and we said, go ahead and try to make an album. You can incorporate new tunes, you can incorporate traditional tunes, you can make adjustments, and then we're going to take this album and we're going to make a backstory, and we're going to send this album around to reviewers to ask them what they thought. So we made a backstory about a family in Ireland that was celebrating their late father, who collected tunes that didn't have a name, and we gathered together and we're going to play these tunes in sets and release this in commemoration of his death. And we got reviews back from some people. It was hard to generate interest because we didn't have tour dates, we didn't have MySpace pages, or pages that described us, the musicians. I didn't play on the album, by the way, and so we didn't want to make up too much and lie too much about what is on the album. But after some time and several positive reviews, we then went back to the reviewers and we said, actually, this album, let's have another gun on 'em. Gun on 'em is Irish for without a title. Involves material generated by an AI system trained on Irish traditional tunes. And every tune here named Gun on 'em comes from material generated by one of these systems. How does this change your assessment of the album? And nearly everybody said the music is still great. The musicianship is awesome. I will still play this album on my radio station. So it was a success. And the involvement of computers or an AI did not make this music sound lifeless like the Daily Mail experiment showed. We obviously we went about this in a way that was sensitive to the tradition. For instance, we didn't name any of the musicians who were professional Irish musicians as being on the album, having contributed to the research. They contributed to the music. They were paid to play the music, but they have professions that are completely separated from this. Another is that we told the reviewers we wouldn't go public with this information about this secret until they have signed off. And if they're not comfortable with that, we will delete and never speak about their review again. And only one person said that, yeah, I don't want to be quoted on this anymore. But by and large, it was a success. You can read more about this and see the tunes and what had changed with the artists in this technical report released at KTH. Also, the album is for free. Listen to it at SoundCloud. So there's 31 tunes in total, 11 sets, 20 of the tunes generated by the FolkRNN systems. Barnarcy had access to all 100,000 tunes, but he only took tunes from 6 of the 34 volumes. And we did not restrict Barnarcy and say, you have to play as it's written. Just use this material as inspiration to go and produce an album. And you can see in the technical report how little they changed on some tunes and how much they changed on other tunes. We also explored this in how this article that's just been published, how music AI is useful, engagements with composers, performers, and audiences. Now, machines generating music is nothing new. We had the Iliac Suite, a string quartet composed by a supercomputer in Urbana-Champaign, 1957. There was music from EDSAC, another supercomputer in Cambridge, composed in 1960, again for string quartet. And now you have many companies, many startups that are taking advantage of the technology is there now to generate convincing music, at least for my TikTok, to accompany my TikTok or to apply to my YouTube videos. And some of these companies do just that, like JukeDeck was just for creating music that fits a particular timeline, has a particular mood, there's a climax at a particular point, and it automatically composes and mixes the final product for you. It was bought by ByteDance, integrated with TikTok, and so that's that trajectory. But you have other companies like Spotify that could be using this kind of technology to pad popular playlists, pad them with their own artists or their own contents to reduce the amount of money paid to real artists. This has not been documented to be really what's going on, but that technology is there to do so. So we have this machine, and okay, you can generate a large amounts of music that appears to be like Irish traditional music. So what? Compared with all these companies and compared with the long history of machine-generated music, what have we done that's new here? So let's get more serious. This was actually all the results of having fun one Saturday morning with somebody else's code. But it developed into several interesting real research questions. The first was, how far can we get with this off-the-shelf vanilla machine learning? There's a lot of work going into proposing new architectures and new kinds of elements of the architecture, activation functions, and training paradigms. But the representation has a very important part in this. So if we just use what has existed for 20 years, more or less, and we focus on a representation that is very expressive and economic with respect to the kind of music we're modeling, how far can we get? We actually get quite far. And Douglas Eck, who heads the Magenta project, which does a lot of AI and machine learning applied to not only music but also art, said this kind of representation that we use is cheat mode for music generation, right? There's nothing fancy here besides a good representation. And that's absolutely true. At least for Irish traditional music, Swedish traditional music maybe, but music in general, no, it's not a good representation. You've got to think about different kinds of music or different use cases of your system. Another couple of questions. How is the system working? It's producing plausible tunes surprisingly well. How is that possible? Where is its knowledge in the 5.6 million parameters? Right? Each one of these layers involves a complex series of transformations and function compositions that are sort of hiding, that are powerful enough to express the syntax over a typical length transcription, which is about 200 tokens long. So here's an example of what goes on, at least in the first layer. We're taking this one hot encoded vector x of t. This is being transformed, rotated, and stretched into a space in 512 dimensions, at least for this input gate. And this for get gate, a different matrix of weights, a different matrix for the output gate, different matrix for the cell gate. We have memory states. So this is a vector, a 512 length vector that contains information about the previous step of the process. This is the recursive bit within this layer. And these are transformed by matrices. And then you have an affine transformation of these linear transformations. So this bias weights. And then you have these nonlinearities, which is compressing the output either with a sigmoid or a hyperbolic tangent. And you have dimension-wise products and an addition, and then a composition of the outputs of an output gate and a compression another compression of the cell gate, producing the hidden state for the current state, the step. And this is passed on to the next layer, which does the same kind of transformation, but on its own hidden states and on the input from that layer, and so on. And what I've done is begin to analyze this in terms of subspaces. So you have a projection of the standard basis in 137. Each one of the elements is one hot encoded, so it's projecting the standard basis into a 512-dimensional hypercube between -1 and 1 in the first LSTM layer, and that has then been projected into a 512-dimension hypercube and 512 hypercube, LSTM3, and then you have an affine soft max transformation, which is projecting that point onto the positive surface of a L1 polytope, which means all of these points on this surface add up to a probability distribution, or they don't add up to a probability, they add up to 1, which satisfies an axiom of probability, and then it's from that point that we sample and we project back into the standard basis. So it's very interesting to look at the action of the matrices and the nonlinearities of the parameters on each one of the layers and see how it's learned and where its knowledge is. And you can read more about, specific, looking at the softmax layer, the 70,000 parameters there, looking at the first LSTM layer. This is ongoing work. It's not easy, but it's fun. Also, some other serious questions. How can we evaluate the resulting models? And how can these models assist or hinder music creation? So we involve practitioners, real folk musicians. We invite them to, not only invite, we pay them to look at the output of our system and evaluate them within the tradition that they know and they've practiced for a long time. We've incorporated using composers and producing concerts with compositions created with the systems. And, these models definitely assist me, but they may not assist other people. The mileage definitely varies. And you can read more about this in a article about machine learning research that matters for music creation, which we talk about at one of the concerts. And my most recent interests are how folk music can improve machine learning research, and what does this mean for traditional music? Where will traditional music be after AI? Is it really a danger? These are some of the questions in a project that's ongoing right now, of which I am the principal investigator, MUSAiC, Music at the Frontiers of Artificial Creativity and Criticism. And you can read more about that at this webpage. I'm going to upload or send Nathan a link to these slides after this talk. Last year, we had a challenge. I organized a challenge that would explore these questions, and it was a public challenge for other researchers doing music data, maybe not doing research in music, but machine learning. Build an AI that generates the most plausible double jigs. A double jig is a form of dance music. The first tune I played, The Boys of Ballinabura, was an example of a double jig, as judged against a collection of 365 published in a collection that is regarded to be an important collection. So 2 prizes were awarded. We had 4 judges that were experts in Irish traditional music, and there was a performance of the best AI jigs at the conference, at a conference on AI music creativity that I organized, and there's more information there. And just released is a video of 2 of the judges talking about the 2 best tunes in the challenge, and they perform these tunes as well. So that's interesting. You can find that on YouTube. The aims of this challenge is to promote meaningful approaches to evaluating music AI. It's not enough that I play a tune on my accordion and say, that's a good tune. It's not enough to look at the statistics of a collection, for the training collection and a generated collection. You have to go deeper. You have to involve exponents of the tradition. Also, we want to see how music AI research can benefit from traditional music and vice versa, and also facilitate discussions about the ethics of music AI. Now the 2021 challenge is open. You are free to submit a system. You can find information about the AI Music Generation Challenge 2020 at that GitHub page, but it is to build an AI that generates the most plausible slang polskas, a form of traditional Swedish dancing. There's data. You can take FolkRNN. You can start with FolkRNN. You can, apply transformer models. You can explore those. You can build simple Markov models. But how well can you do? And again, 4 judges of expertise in Swedish traditional dance music and slang polskas, obviously, will be judging. So I will end with what one person has called a soulless Swedish tune, själlös svensk låt. It's kind of play. I don't know as much about Swedish traditional music as Irish traditional music, but I know a little bit of where to tap my feet if I'm playing a particular kind of polska. And so I'm going to play this polska for you to end. And I actually call it Måndag på KTH because it has that feeling. You can follow me on my adventure of learning a machine folk tune a week at Tunes from the AI Frontiers. Many of the tunes are becoming about my dog, Shugi, there. And if you want to do more, you can actually look at the Society for the Preservation and Promotion of Machine Folk Music. We've got millions of tunes, but nobody around to play them. The Society is dedicated to expressing the good news that we have so much more music that we could learn, and interesting music that is of today and generated by machines of today rather than people of 100 years ago. And the good news is we can play it as if we've been playing it for hundreds of years. So with that, I thank your attention, and I'm happy to take some questions.